Hi viewers, this is Sri Ramulu. So today's topic is N-type semiconductor. See here, when a small amount of pentavalent impurity is added to a pure semiconductor crystal during the crystal growth, the resulting crystal is called as N-type extrinsic semiconductor. We can say it is N-type extrinsic semiconductor or simply N-type semiconductor. See what is when a small amount of pentavalent impurity. So what are the impurity definitions and about the intrinsic extrinsic semiconductor I explained one video. So please watch that video, then you can understand what is impurity. Okay, here pentavalent impurity, pent stands for 5. Okay, valent means valency, 5 valence means that is a fifth group element, that is the meaning of this. So when a small amount of pentavalent means a fifth group element as a impurity is added to what, pure semiconductor. Okay, so when we add the fifth group element to the small amount, only small amount of fifth group element to what, pure semiconductor. So when a crystal is growing means when a crystal is preparing. Okay, so during the crystal preparation, the then resultant crystal, what you call, we call simply it is n-type extrinsic semiconductor. Okay, for example, let it is on pure form of semiconductor. For this what I am doing, small amount, very small amount of pentavalent impurity is adding. So when we add pentavalent impurity to it, then what happens, then it becomes a n-type semiconductor. Okay, and the diagram is also given. That diagram I will explain later. First let me explain. Let us consider the case when pentavalent arsenic, here I have taken fifth group element 1 as arsenic. Arsenic is added to pure germanium crystal as shown in figure. So let it is on pure germanium crystal, to this pure germanium crystal arsenic what, impurity. So it is a pentavalent impurity is added. Okay, see here in the beside picture. The the arsenic atom fits, means it is set, fits in germanium crystal in such a way that its 4 valency electrons forms covalent bond with the 4 germanium atom. So actually germanium atom is a fourth group element, means it contains a outermost cell 4 electrons only. So 4 unpaired electrons present. Okay, so if this germanium want to become a pure perfect stability element, then it requires again 4 extra electrons. Okay, then only it becomes stable and obey the octet rule, means 8 electrons like this. Okay, 2 4 6 and 8 electrons, octet rule. Okay, here arsenic atom fits in germanium crystal in such a way, that means how it is. Okay, it's 4 valency electrons. Whose 4 valency electron, right? Germanium 4 valence electrons forms covalent bond with the, right, sorry, arsenic containing generally arsenic is a fifth group element. Fifth group element, how can we decide? So we can easily say the valency, number of valence depending upon the number of valency electrons. If there are the 4 valency electron, that is a fourth group. 5 valence electron, fifth group. So fifth group means 5 valence electron present. Among 5 valency electron, 4 valency electron easily form a bond with the germanium atom. Then what we get? We get one extra electron. So see here that I will explain about that extra electron. Okay, the fifth electron of arsenic atom, just now I said you fifth electron. So like this, 4 electron and one more fifth electron. So these 4 already forms bonds with the germanium. And next, fifth electron of arsenic atom is not covalent bonded, but it loosely bound to the parent arsenic atom. So it loosely bound with this atom. That means, so the small amount of energy if you give, it easily come outside from the attraction of arsenic. That is a loosely connection. This electron is available as a carrier of current. So this electron is available as a carrier of current, means for responsible for current, means production of current. See here the diagram, right? It is a germanium atom, sorry, it is a pure form of semiconductor. So to this, what I have done, I have added impurity. Which impurity? As arsenic as a impurity. So let it is arsenic. Arsenic actually, how many electrons it contains? 5 electrons. 1, 2, 3, 4, and 5. Among the 5, 4 electrons already forms the bonds with the neighboring germanium atoms like this. Okay, then one electron is a free, so it is loosely bonds with this, so it is a free electron. One arsenic atom is giving one electron. If we add the small amount of arsenic atom, then what we get? We get a millions of million electrons. So that is why electrons are negatively charged particles. So that is why we call this material as a n type, means negative type semiconductor. N type stands for negative. Okay friends, so like this. Okay, let me explain boards. The amount of energy needed to detach this fifth electron, valency electron from the impurity atom is of the order of 0.01 electron for germanium, 0.05 electron for silicon using as impurity. So if you want to remove the electron, then this much of energy is required, right? This energy is very small and may be provided. So which energy which we give to detach the electron, fifth electron. This energy is very small and may be provided with the thermal agitation at room temperature. So if you want to remove this electron, the energy is required. That energy from where we can give? We can give from the room temperature only. So that means at 20 at 27 degrees Celsius only. Now, such a liberated, means emitted, valence electron is then free to move in the crystal lattice in the same way as the free electron in the intrinsic semiconductor. Okay, how the electron moves in intrinsic semiconductor, in the same manner here also it moves. That is things. Although each arsenic atom provides only one free electrons, right? One arsenic can give one free electrons. Yet an extremely small amount of arsenic impurity provides enough atoms to supply millions of free electrons. If we want to get millions of free electrons, then what we need? We need small amount of arsenic impurity we have to add to what? Pure germanium crystal. Okay, semiconductor crystal. Then we get millions of free electrons we get. Okay, the fifth group element are called donors because they donate an electron. Arsenic is giving one electron. If there are the two arsenic, they gives two electrons. So they are giving means they are donating electrons. So that is why they are called donor. The energy band description is shown in figure. Energy band description also given. So I will show you. Energy band, see here. This is the energy band. Okay, energy band description it is a valency band, and this is conduction band. Okay, in conduction band only electrons present. In valency band what present? Holes present. Right. Okay, the energy band description is shown. Okay, as seen in a addition to the electrons holes available in pure germanium. So just now we have seen in valency band we have seen holes. In conduction band we have seen electrons. Okay, available in pure germanium. In addition of arsenic greatly increase the number of conduction electrons. Okay, so here as seen, in addition to the electrons, not only electrons, holes also present, okay, available in pure germanium. In addition to the arsenic greatly increase the number of conduction electron. So this what arsenic can give, it add more number of electrons, conduction electrons. Thus, concentration of electron in conduction band is increased. So, like this, concentration of electron. Concentration means more number of electron has to present for smaller volume or area. Okay, conduction band is increased and exceeds concentration of holes in the valency band. Okay, so in valency band less number of holes present, but in conduction band more electron present. Why? Because every arsenic atom can give one electron. Okay, so that is why here more electron present means negative charge present, so that is why we call n type it is. In n type semiconductor material there is an excess of electron. Yes, here the number of holes is small in comparison to the parent intrinsic semiconductor. Yes, holes are very less. So that is also shown in diagrams here. Here less number of holes are shown and more number of electrons are shown. So this point dot can indicates electron, and this simply circle, like a circle, unfilled circle can show holes. So these are filled circles are electrons. So it is a conduction band, it is a valence band. In conduction band more electron present, in valence band less holes present. Okay friends, thank you watching for this video.